Okay, let's do this. Let's do a couple from the web work, the number 3 and 4. So I've got 6 over 1 plus 81x squared. And this is pretty straightforward because it's basically in the form a over 1 minus r. So we can directly apply a geometric series to this function to rewrite it as a series. So before we do that, though, I want to point out one thing. Just what if we had something like this? So say I want to write this as a series. Am I ready to write it in terms of a geometric series? Okay, what's the problem? 3. Okay. It has to be a over 1 minus r, right? A over 1 minus r. So, but that's a pretty easy fix. I need to maintain this function, but I need a 1 there. So I can only do things like multiply by 1, right? I got to keep the value of the fraction the same. So yeah, so if I take 1/3 of this, that will give me, or divide by 3, that will give me a 1 here. But now that just changed the value of this. What else would I have to do? So the top also. So if I do 1/3 over 1/3, or divide the top and bottom by 3, then that'll get me a 1 there, and maintain the value of or maintain the rule of the function. So it'd be 4/3 over 1 plus 1/3 x to the 4th. And now I'm ready to go, right? So now I can do this. It's still the same function f, but it has the 1 here, so I can apply the a over 1 minus r. So watch out for that. It's got to be, if you're using the a over 1 minus r, it has to be a 1. And if you don't have a 1, then just start by dividing both top and bottom by the value that you have to get 1. Does that make sense? Okay, let's do this one then, which has a 1, so that's not an issue, but just wanted to show you that. Okay, so for this one, a is 6, r is, so it's going to be 1 minus r. So r would be negative 81x squared. And we can just write it down. So it's going to be f of x will equal n equals 0 to infinity of 6 times negative 81x squared to the n. Okay, so we essentially have the answer, but they want the coefficients for this general form of a power series. Meaning, they want, what is the coefficient for each value of x exponent, right? So when x is to the 3rd power, what coefficient would you have? Well, that'd be c3 when you have x cubed. When you have x to the 7th, this would be, the coefficient for that one would be c7. They would want to know what c7 is. So what we want to do is we want to write this out. You know, remember, see this, think what, right? See this, think what, and then just get our exponents. Look at our exponents of x, exponents of x, and for the what? The 4th exponent of x, all the other stuff is going to be c4, right? All the other stuff multiplied by x to the 4th will be c4. So that's all this is saying here, and that's what hopefully you got out of that little video clip. Okay. So we want to write this out. So let's go ahead and just do one more step of simplification first. So I got 6 times, we can just leave it as negative 81 to the n, that's fine. And then x to the 2n. And I think that's good enough. Okay? So, see that? Think what, right? See that? Think what? Write it down. See that? Think what? What does that equal? You don't have to do any simplifying. Just if you want to just leave things so that no computation required. You just leave things in unsimplified form. Okay, Ryu, you're up next on the list. Tell me. What would it be? So what? So the task that I gave you, what does this thing equal? So we'll do this later. We'll do this later. So what does this sum equal? Okay. Okay. Can I just say x to the 0? Okay. Then. Okay. Uh-huh. Okay, I think that's good, yeah. On and on and on. So did you write, is that what you wrote, or something very close to that? That's what you should have wrote. So what we need now is we need the coefficients, C0, C1, C2, C3, C4, so that this will equal exactly what we have, right? So what coefficients of the different powers of x will produce exactly the same sum? All right, so C0, well, that's the coefficient of x to the 0. What is it? 6, right? This is 6 times 1, so 6. All right, C1 is the coefficient of x to the first. So we look at this. What coefficient of x to the first is going to help me reproduce exactly this sum? There is no x to the first, right? There is no x to the first term. So I want to make sure that there is none, right? So I'm going to make sure that there's no x to the first term, so that coefficient has to be. Doesn't make sense. So if you want to have a x to the first term in there, because you want all of them, x to the first, then we're saying what times x to the first is going to ensure that I have this sum right here. Well, there is no x to the first term, so it's got to be 0. It's got to 0 it out. Doesn't make sense. All right, and then x squared. So C2 is asking for the coefficient when the power of x is 2. What's the coefficient? 6 times negative 81. What coefficient of x cubed do I need to get exactly this sum? Another 0, right? There is no x cubed, so I got to make sure C3 is 0 so I don't have an x cubed term. Okay, what's the so C4, that's the coefficient of x to the 4th that's going to reproduce this sum. 6 times negative 81 squared. All right, so doesn't make sense. So what coefficients of the general form of the power series are going to reproduce our series? That's what we're saying. So each coefficient is just the corresponding coefficient of x to that power. Questions on number 3? Anybody have a question on this one? Can I erase? Okay, next problem. Now this one. So is this in the form a over 1 minus r? No, it's not in the form a over 1 minus r. So what do? We really have a over 1 minus something all squared. And we talked last time about how to handle something like this. What do? We're going to start with something we know that we can relate to this, right? So what's something easy that we can start with? And I'll call it something else, like called w. Yeah, so the problem here is this whole denominator is squared. So if I just had 9 over 1 minus 10x, I could do that easily. So let's do that and then see what we can do to w to reproduce f, okay? So what's that? That's going to be n equals 0, a times, this time it's just positive 10x, right? And I want to write out some terms here. Sorry, to the n. And if we want, we could do 9 times 10 to the n, x to the n. Either way, same thing. So we're going to write out some terms here. When n is 0, we get 9. When n is 1, we get when n is 2, we get 900x squared. Do one more. 9,000x cubed. And so on, right? That's just the fourth partial sum. It would keep going, right? It would keep going and would increase to infinity. Questions so far? And so how does f relate to w, or is very close to what about w? Remember what we said? It's derivative, right? Because this is really, so I'll do it over here. So w is really 9 times 1 minus 10x to the minus 1. And so w prime is negative 9, 1 minus 10x to the minus 2, right? Times negative 10 by the chain rule. So let's write that out. So what is that? That's 90, positive 90 over 1 minus 10x squared. So I'm going to write that here. So I'm going to do the derivative, and I'm going to do all these different forms. I think it's very helpful. Do it. So what is it? It's w prime. And we just found out that it's 90 over 1 minus 10x squared. All right, and so then let's work on this form of it. So what's the derivative with respect to x? Again, let's hold off on the index. So with respect to x, what do we get? 9, 10 to the n. All that doesn't care about x, right? Derivative of x to the n is? And x to the n minus 1. And as a check, as long as we know we got those individual terms right, we're pretty confident we can get those right, and it's a good way to check. So derivative of the expanded form, right? Derivative of 9 is 0. Derivative of 90x. 1800x, 27,000 x squared. Okay, is w prime equal to f? Is that what f is, w prime? It's very close, but not quite. What do we need to do to w prime now to get f? Right, so this is 90 over the denominator. F is 9 over. So if we want F, what are we going to do to W prime? Divide by 10. In our example, it just happened to be that the derivative was exactly the function that we wanted. In this case, the derivative is 10 times the function that we want, so we got to divide by 10, and then we'll have F, right? If we divide W prime by 10, we'll have F, which is 9 over 1 minus 10x squared. And so what's going to happen when we divide by 10 here? So what will get affected dividing by 10? 9 times 10 to the? So what is this? N tens multiplied together, and I'm going to divide by 110. So now how many tens do I have multiplied together? N minus 1, right? Having that concept of exponent as, oh, I'm multiplying that thing together this many times is going to really help you with all these little simplifications you need to do. Okay? And all the rest is the same. So then all these divided by 10 is 0 plus 9 plus 180x plus 2700 x squared and more. Okay, so if we did everything right, we've got our power series for F, the one we were given, 9 over 1 minus 10x squared. So what we should do now is we should check, I think we can be the most confident we did this right side first, the individual terms, right? Because it was just taking the derivative of easy polynomial and then dividing by 10. So it's a good way to check to make sure that the series form that we ended up with is going to give us those terms. So it's a good check. So, does it? So here's where we got to really watch where we're going to, do we want to start at n equals 0? Do we want to start at n equals 0? Well, gives us a 0 there. Let's see, x. Yeah, it kind of doesn't matter, right? So if we start at n equals 0, there's an n, and so then it goes away, and then there's our 0. And then so then n equals 1, when we plug in n equals 1, what do we get? 9 times 10 to the 0 times 1 times x to the 0. And does that equal 9? 9 times 10 to the 0 is 1 times 1 times 1. That gives us 9. Okay, and so then the next one, let's check n equals 2. 9 times 10 to the first is 90 times 2 is 180 times x to the 2 minus 1, x, it works, 180x. So you see what I'm doing? I'm plugging in my values of n to make sure I'm getting the exact same terms over here that I did when I worked the polynomial. So we could start with n equals 1 or 0 because this first term is a 0. And now we're back to our question again of, but now looking at this is going to help us put these coefficients in, right? It's the same thing. C0 is the coefficient when x to the 0. So when you have x to the 0, what is the coefficient? 9. C1 is the coefficient when you have x to the first power. 180. C2. All right, so we need some more. So what's going to give us C3 is when n is actually 4, right? Because when n is 4, we get the x cubed, and that'll be C3. So when n is 4, what do we get? 9 times 10 cubed times 4. So we can just put it in like that. 9 times 10 cubed times 4. So maybe this is a good chance to actually shift the index, right? Because now, so our sequence is in terms of, oh, I shouldn't have done that. What was it?
9 times 10 to the n minus 1 times nx to the n minus 1. There's another n.
Okay, so this would be a good chance to shift the index, right? Remember? And in order to do that, what do we want to do? We want x to be to the n power, so we want this to go forward 1. So we want to move this back 1, but we don't want to start at -1. So remember that we said that this is the same as starting at n equals 1, right? We said we could start at n equals 0 or 1. And so by starting at 1, now we can do this thing that we talked about last time or Monday, shifting the index so that we actually do have our series in terms of x to the n. And what did we say about that? If I want this to be x to the n, right, then what am I doing? I'm going to increase all these n's by 1. So then I'm going to have n plus 1. And then there's a 9 there. And then 10 to the, what, n. But that's, so if I've increased n by 1 here, that means I have to start with n equals, no, I am starting with n equals 1, right? So when n equals 1, okay, you missed it. So what I said was, remember before we said we could have started at 0 or 1. So for shifting the index, we want to start at 1 because we don't, I'm moving n forward by 1 here. So what do I have to do with to n so that we get the same? So let's write down what the first term is. The first term is 9 times 10 to the, what, 0 times 1 times x to the 0. Okay, hold on a sec. So 9 times 10 to the 0, that's the first term, right, when n equals 1. And so now, if I want to write these all in terms of n1 greater, x to the n, n plus 1, 10 to the n, what does my first value of n be so that this is my first term? Has to be 0, right? So in the formula, if you shift n in the formula, if you go up 1, that means you've got to start at n1 lower to get the same terms. It should make sense. So I increased n by 1 in the formula, which means I have to get the same terms, I have to decrease n by 1 where I start, right? Then I'll end up generating the same terms. Okay, so that was to make this part easier, right? So now I have in my formula of x to the n rather than x to the n minus 1. Okay, so C3 is going to be now when n equals 3. That's just easier to handle. So n equals 3, we're going to get 9 times 10 cubed times 4. See that? So now we have the same thing we did there. And now when n equals 4, 9 times 10 to the 4th times n plus 1, or 5. Okay. Anybody have a question on that? So shifting the index is an important thing that is helpful, and like in this case, it was helpful to get these coefficients because by shifting the index, then I had x to the n in my formula, which makes coming up with these coefficients a little easier. Ask me if you're not sure. Yes, please. Yeah.
Would it maybe be more straightforward to just take the integral of that and then take the derivative of the summation?
That'll work, but the technique that I'm showing you will work for all of them. Find a similar, so yeah, and then there's more chance to make an error when you do derivative, then go or integral, and then back to derivative. You do both. I think there's more chance to make an error, and there's certain problems that won't work on. So in some, yeah, you can do that on some problems, and if you're more comfortable, then that's okay. But I don't think it's as universal as this. And I also think there's more chance for error. Other questions? Okay, let's try some more. These are, if you started like this. This is going to be trouble. Why? So this would be consistent with what we did in the previous examples, right? But this is going to be, there's going to be trouble with this. Why is there going to be trouble with this? And what does that mean then? What's going to happen? When you take the derivative, what is that going to require? Quotient rule. Quotient rule, right? Which then it'll be nothing like f. So don't erase. Okay? The work you've done is still okay. What we want to do is we just want to do this. We can multiply by x later. We can just multiply by x later. Okay? So this is what we want to do to start. So if you did some work, it's probably still okay. You just don't want to do x over, because when you do the derivative, it's the quotient rule, which will be nothing like f. Do you see? Okay? Okay, did you get the derivative? So the question is now, what do we do with that to recover f? So we got this, I end up with negative 2 over 1 plus 2x quantity squared, and I need f. So what am I going to do with g prime to get f? Where's Ryan Thompson? Where's Ryan? Multiply by x. So if I multiply g prime by x, that will give me f. So if I multiply by x, I'll have negative 2x over 1 plus 2x quantity squared. Is that f? Okay, well, it's part of it. What else do I need to do? Divide by negative 2. So I really want to multiply by what? X over negative 2. I want to take g prime and I want to multiply by x and I want to divide by negative 2, and that will make the function f out of g prime. But then when I do that, I'm going to multiply by x over negative 2 for all of them, right? So when I multiply by x over negative 2, I'll get x over 1 plus 2x quantity squared. All right, and now I just have to be careful with my summation too. So when I multiply by x, what's going to change here? X to the now n, right? I'm going to have one more x to multiply, and that will give me n x's multiplied together rather than n minus 1. So I'll have x to the n now. And if I divide by negative 2, then my negative 2 will be to the, again, I have n negative 2's multiplied together. I'm going to divide by negative 2, so I'll have one less negative 2 in my product. So I'll have one less. N doesn't get changed by that. And I'm going to do this, all these terms, divide by x over negative 2. So I'm going to get 0, or multiply by x over negative 2. So I'm going to get plus x minus 4x squared, is that right? Plus 12x cubed minus 32x to the 4th. Am I doing the math right? So all of these are equal to g prime, and all of these are equal to g prime times x divided by negative 2, which is the same as f. So now the question is, where do we want to start n? Can we start n at n equals 0? Looks like we can, right? N equals 0, we'll make this 0. N equals 1. I should get, if I put in n equals 1, I should just get x. Do I just get x for n equals 1? Let me see if you have any questions. Does anybody have a question? You follow this? If I lost you, ask. There's lots of details. I know this is tricky. If I lost you, please ask. Yes, please. Uh-huh. No, I did. I'm doing it on every part. So I did it here. I multiplied by x and divided by negative 2 here. And I did it here. And I did it on all these. And the reason I chose that was because that's what I needed to get f here. So I looked at this and I said, how do I need to adjust this to get f? Well, I need to get rid of the negative 2 and I need an x. So that's why I chose this factor of x over negative 2, so that when I multiply this by x over negative 2, I'll get the function f. So if I do it to that, I'm going to do it to that, and I'm going to do it to all of these. Did I answer your question? So I chose this by looking at what did I need to multiply g prime by to get my f. So g prime times x over negative 2 is f. This times x over negative 2 is this. This times x over negative 2 is this. And all these times x over negative 2 is all these. So it's all 4 of them. Other questions? Yes, please.
Does it always work that it could be 0 or 1?
No, so that there's different situations that come up. So that's why I really recommend that you follow it through with a polynomial, this form over here, because that will help you figure out what the index has to be. Again, that's working here because the first term is 0. Yeah.
So it doesn't matter as long as we
So your summation form needs to get you these terms, as long as you've done the math on these terms right. So I did the derivative, and then I did times x over negative 2 to get these polynomial terms. So then that's a way to check to make sure that your summation form is producing exactly those terms. Other questions? Yes?
Can you manipulate g of x so that its derivative is g prime of x?
I missed the beginning. Sorry, can you start again?
Can you manipulate g of x so that its derivative is just g prime of x, which is f of x?
That would be tough, right? So what do you want to do to g so that the derivative is x over 1 plus 2x squared?
Well, I just made g of x negative 1/2 1 plus 2x be negative first, and then from there.
So you took care of the negative 2, but you still have to multiply by x.
Yeah.
Yeah, that's fine.
Okay.
Yeah, so you started with, yeah, that's fine. Yeah, so constants are, you can work with constants very easily. It's that x that was the problem. We needed to leave the x off because the quotient rule would mess this up badly. So we save the x for this last step. And so then Elmer, here's an example where your thing won't work, right? Because you don't want to integrate that. It's not x over 1 plus, would require some heavy duty technique, and then now you're,
But if you do it at both the x out, and set the integral and everything.
yep, yep, yes,
And
yep.
not-
yep, you're right. You can do it though. That's okay. All right, other questions? All right, so at least want to start one more. So, answer here. This is a power series for this function, right? So it's a polynomial version of x over 1 plus 2x squared. Now we didn't find the interval of convergence, but that's just using the ratio test, right? Use the ratio test on this. We did it a couple days ago to get your interval for the values of x for which this series is a valid representation of f. Okay, so it's not gonna work for all x, right? It's only gonna work in the interval for which that series converges. Will that series reproduce f? Okay, it's not for all x. Okay, this. Okay, so like the last one, we can kind of put the x squared on hold, right? So we know that we can just multiply by x squared when we need to, okay? So we really want to focus on natural log of 1 minus x squared and try to figure out what the heck does that have to do with a over 1 minus r, right? What does it have to do with a over 1 minus r? So what could we do to natural log? How does it relate to a over 1 minus r? Anybody see it? What's that? All right, so you're saying the derivative of what? Yeah, no, notice, right, what is the derivative of, oh, jeez. What is the derivative of natural log of 1 minus x squared? So derivative of natural log of 1 minus x squared is 1 over 1 minus x squared, is that it? Times negative 2x. So if I want to, I could start, so this now looks, this is something I can definitely do. Negative 2x over 1 minus x squared. I can handle that. A over 1 minus r, right? So if I found the power series for that, a over 1 minus r, what am I going to do to that power series to get something like j? I would need antiderivative, right? So we'll start with this. So we'll call it, who knows? Call it z of x. I'm going to start with this, negative 2x over 1 minus x squared. I'm going to write the power series for that. Negative 2x times x squared to the n equals negative 2x minus 2x times x squared minus 2x times x to the fourth, etc. And what did I say? The integral, so antiderivative is going to give me natural log of 1 minus x squared. So I'm going to rewrite this as negative 2 times x to the 2n plus 1, right? Is that x to the 2n plus 1? And now I'm going to do antiderivative of x to the 2n plus 1. Antiderivative. Still going to have the negative 2. And so when I do antiderivative, I'm going to have x to the what? 2n plus 2. But then also over 2n plus 2. And then likewise, antiderivative of all these. Okay? I won't do those now. Is that my function j? How do I get my function j from that now? So what I have now is a power series for natural log of 1 minus x squared. I need to multiply by x squared to get j. So times x squared equals x squared ln 1 minus x squared. So what I'm going to have, x to the 2n plus, how many x's do I have now? X 2n plus 4, I have 2 more, right? Times 1 over 2n plus 2. And then we just have to figure out where does it start? You can figure out where it starts, again, by working through your polynomial terms. Do the math on your polynomial terms, check back, and that can help you determine where it starts in that.